Hello everyone and welcome to another video in the Mastering Flask video course. In the previous section, we worked with Celery to program asynchronously. This is the start of section 10, which is titled Testing Our App. In this section, we will look at what unit testing is and why it will be beneficial to your app. We will cover the basics of unit testing, then we will go over the various specialized methods of testing the different parts of our app. We will also explain the concept of code coverage at the end of this section. This video is titled, What is Unit Testing? In this video, we will answer the question, What is unit testing? We will also go through a hypothetical unit test, as well as write the first simple tests of our application. So, what does it mean to test software? Testing software is very simple. All it involves is running particular pieces of your program, like a simple method, a few classes or a whole module, and saying what you expect the results of that piece to be, and comparing it to what the results from the piece of the program actually are. If the results are the same, the test passes. If the results are different, the test fails. This simple mechanism verifies that your code is functioning properly without any human error or misconceptions. Typically, these tests are run before the code is deployed to the line server in order to make sure broken code is never seen by your users. But in relation to software testing, what are unit tests? In testing, there are three main types of tests. Unit tests are tests that verify the correctness of individual pieces of code, such as functions. Integration testing, which tests the correctness of various units of programs working in tandem. And the last type of testing is system testing, which tests the correctness of the whole system at once, rather than individual pieces. We will be focusing on unit tests for this section, as integration and system tests rely heavily on your personal production environment and not on Flask. Let's go through a hypothetical example. If you had a function that calculated the average elements of a list, you would test if the function was functioning properly by giving it the list 1, 2, 3, and test if it gave back 2. Validity in Python is tested with the assert keyword. What assert does is run a Boolean test, and if it returns true, it does nothing. But if it returns false, it throws an error. Here are some examples of assert statements to test if our function is working correctly. Given a list of 1, 2, and 3, we expect 2. Given a list of 0, 50, and 100, we expect 50. And that's really all there is to it. All unit testing is, given some set of inputs, what do you expect the output to be? Now that we understand the mechanics of unit testing, we can start adding unit tests into our application. The first step is to create a new folder called Tests in the root of your project directory. The first test that we will write before getting into more advanced tests is if our application's createApp function correctly initializes our app object with the correct configuration values. To do this, we will use the unit test library in Python standard library, which will take care of running all of our tests as well as providing some helper functions. First, create two new files in the test directory called test.config and init.py. In the init.py file, import the createApp function and create an app from dev.config. In the test_config.py, import the created app object. Tests are created with the unit test library by creating a class in the file that inherits from the unit test test case. This class name must also be prepended with the word test. Each test will be a method of this class and is differentiated from the other methods of the class by also prepending them with the word test. There's also the set up and tear down methods. Which are called by the unit test library before and after every test respectively. We'll use these later in this section. So now we can start writing our first test. Create a class called test.config that inherits from unit test test case. Next, we will need a method called test_config_loading, which will test if the createApp function correctly loaded our dev_config object. This method will have two asserts, one to test the debug option and one to test the SQL Alchemy database URI. Now we can run the test we have written. Go to the root of your code and run Python m unit test. This command uses the unit test library to automatically find any tests that you have written and runs them. As you can see from the output, I found one test and it completed successfully. Great! We are now at the end of this video. So far, we have learned what unit testing is, how to do it in Python, and we have written our first test for our application. In the next video, we'll start writing tests for our SQL Alchemy models. Hello and welcome back. In the previous video, we learned what is unit testing. This is video 2 of section 10, titled Testing Our Models. In this video, we are going to cover how to test the unit test library to make sure our SQL Alchemy models are functioning properly. The first step we are going to take is to create a specialized test configuration object. This will allow us to test our SQL Alchemy code without disturbing our development database. It is going to look almost like the dev_config object without some of these unnecessary values, and we will also change the SQL Alchemy database URI value to SQLite. The new SQL Alchemy URI creates a new SQLite and is destroyed when the test runner ends. Also, change the app in _init_.py to use the newly created test_config object. We will need the setup method that I mentioned in the previous video. Each of the tests in this test case will need the DB object also. Because we are working outside the Flask application context, we will have to manually modify our DB object to correctly link with our application object. Finally, we need to create all of our tables in the new database with the create_all method. Next, we'll need to define the teardown method to make sure that the modifications from one test do not interfere with another test. In the teardown method, we will call db.session.remove to clean up the session, and db.drop_all to drop all of the tables. The first type of test that covers models is testing if they initialize correctly and can be saved to the database. Using the user model as an example, and then queries the database to make sure that the user is correctly saved. The second type of test we will write for our models is testing the methods on the models. If your models have utility methods on them, like our user objects method for setting and checking passwords, then it's best that we test those as well. In a new test method called test_user_password, we will create a user object, set its password, and then use the check_password function to see if it was correctly saved. The third type of test that we will cover in this video are tests that check relationships between models. In a new test method called test_role_relationship, we will test the relationship between the user model and the role model. First, create both a user and a role object with the role object saved to the user object and commit them to the database. Then, query for the first user object with the role that we saved and check if it represents the same row in the database as the original user object we saved. Here we could have created one big test instead of 3 smaller ones. However, it is a good practice to make smaller tests separated from each other. Okay, let's test our app. And we have an error here. This is because we've updated the config, but not the test that tests config loading. Let's fix it real quick. They work. Excellent! We have created 3 different types of tests in which to verify that our model code is functioning properly. If you apply these 3 types of model tests to all of your models, then you can be sure that every piece of your SQL Alchemy code is working. In the next video, we will cover methods to test if your view functions are working properly. In the previous video, we saw how to test our models. This is video 3 of section 10, titled Testing URLs. In this video, we will cover some specific methods to test Flask view functions, as the tools we have seen so far are not adequate. But we will not be testing the behavior of each page in the browser, since it is only remotely related to Flask. In a new file called test_urls.py, we will need another test case class called testURLs. We will also need the set up and tear down methods from the test models class in the previous video, with one small addition. In order to test the functionality of our view functions without having to run the test server, we will use a little-known feature of Flask, the test_client object. The test_client allows us to make simulated HTTP requests to our view functions and get the response objects back. To make the test_client available to each of the test methods, save it to the instance variable client. Like in the previous video, this video will not create every test that should be created for your view functions. Rather, this video will cover some different types of the basic tests that can be created to test your view functions, which will give you the tools to cover all of your functions. The first basic test that we will create is a test to make sure a page is returning successfully. In a new test method called test_home, we will use the get method of the test client in order to simulate a GET HTTP request to the /URI and save the result. The test client provides methods for all of the standard HTTP methods as lowercase versions of the method names. The result variable is just a Flask response object, so we can easily tell if the function completed successfully if the HTTP code is equal to 200. If you want to check the content of the page, for example, to test form submissions, then you can examine the contents of the returned page using the getData method of the response object. Another test that we can perform is to test if restricted pages keep out logged out users. Building off of the last test, all we need to change is the URL to one of our Flask admin pages and status, instead of code 200 to 403. As you might know, HTTP has many different status codes. You can find the list of them at this Wikipedia page. We can also test if our login mechanism works with the test client. In a new test method called testLogin, we first need to create a new user object to log in with. After the user is saved to the database, we can use the post method of the client to send a post request. If we post to the login page with our new user's username and password, and if we tell the function to follow any redirects, we can test if the phrase "logged in successfully" is present in the resulting page. Now that we have a mechanism to log in, we can also test if pages that require logins correctly let a user in once they are logged in. Using the testLogin method as a base, we will need a new test method called testAdmin_logged_in. In addition to creating a new user, we need to add an admin role to the user to allow it to access the admin pages. Also, we need to add a GET call to the user admin page and change the assert to check if the status is 200. Let's run our tests. Excellent! They work! Great! In this video, we explored a little-known feature of Flask and used it to test the functionality of our view functions. You now have everything you need to write tests for all of the features of your web application. In the next video, we will cover the concept of code coverage and how it can be used to make sure your tests are of good quality. In the previous video, we tested URLs. This is video 4 of section 10, Testing Code Coverage. In this video, we will discuss the concept of test coverage, and we will cover how to get it for your tests. So, what code coverage is the percentage of your code that is executed during your tests. That's it. This simple statistic is extremely powerful, as it gives a definite measure of the quality of your tests. If your tests are only covering 50% of your code base, then your tests need some serious improvement. Typically, you want to aim at 95% coverage, as there is always going to be code that isn't feasibly testable. To get the coverage of our code, we need to install the coverage package from pip. Next, we need coverage to run our tests, which we can do by running the command coverage run source wfdb m unit test discover. This command simply tells coverage to run our previous test running command and only measure the coverage of the files in the wfdb directory. After your tests run, a new file called coverage will be made in the directory of your project. We can get some basic statistics from this by running the coverage report. As you can see, the tests are only covering 63% of our code. But this is a rather simplistic method of looking at your coverage, as you can't tell explicitly what parts of your code are missing. Thankfully, we have the coverage HTML command, which creates a report of all of our code in a browse-able manner. After you run the command, you should see a new folder called HTML_cov in your project directory. If you open the index.html file in your web browser, you can start browsing a specialized view of what code is and isn't executed in your project. As you can tell from this report, I never made any tests for the Movie API, or any API for that matter. And now that I have this information, I know exactly which tests to improve, or what new tests to write. Let's wrap up what we covered in this section. We learned what a unit test is and how we could do it in Python. We also learned specific methods of how to unit test our SQL Alchemy models and view functions. And finally, we learned what code coverage is and how to use it to write better tests.